So I'm going to talk about the WaPLUGIN in QGIS, but unfortunately not about the downscaling because we were waiting for a contract and things are very bureaucratic. So the team that develops the WaPLUGIN still waiting for signatures from FAO and IHE Delft Institute for Water Education. So we hope next time we can give you an update about downscaling. But what I will do is give you an overview about the plugin. I'm a bit curious because previous presentation in this session was about nuclear stuff, and the next presentation will be about water sanitation, I think. This one's about water and agriculture. So who here in the audience works with water and agriculture? Okay, at least one, two, three, a bit. Yeah. Okay. Let's see if this might be helpful for you. So, and I had to stick under 10 megabytes and have animations. So that was a bit of a challenge. So we lost a lot of graphics to make sure that you will see animations at least. The problem is that water is or agriculture is a very large water user. And a lot of water is also wasted during irrigation. And we are irrigating more and more areas in the world. We lose water by evaporation when we are not very efficient in applying the water. Also, the application of water and irrigation is not uniformly distributed. There can be problems that some areas get more water than others. There can be wind drift, and you can lose water by runoff. And we have a solution where remote sensing data can help. We can assess, for example, which crops are stressed by water. We can predict crop yields. We can monitor the climate and the weather. And we can estimate evapotranspiration from space. And for that purpose, the FAO has established a portal for sharing data for crop water productivity. And it delivers all kinds of data sets derived from mostly Sentinel data, but also other data sets, combining it to deliver products on evapotranspiration, on biomass, and other things that are important if you work in water and agriculture. And version 2 was launched in 2019 and covered only a part of the world, Africa and the Middle East. And the data is available from 2009 to 2023. But more recently, there's version 3 that was launched in October 2023, and that covers the whole world. And the data is available since 2018. And it covers the world in different levels. So the global, so also for your countries, it's available at 300-meter resolution. And then there's the level 2, the national level, as we say, that's 100-meter resolution. That's for Africa and the Middle East. And there's the subnational level, which is for certain project countries at 20 meters. But there's also a WaPOR script, which you can apply to download data yourself and to process the remote sensing data to 20-meter resolution for your own study area. But if you want to have the ready-made data, you can go to the links on this slide to download the data from the portal. But as GIS specialists, we would like to download the data not manually from a website, but if we are using QGIS, we would like to have that step skipped and just get it directly into QGIS and clipped to your study area. So that's what the people from the WaPLUGIN team made for us. So they integrated the WaPOR portal from FAO into QGIS. And it has a very nice story because we had, I think it was around COVID 2020, the first online hackathon for WaPOR, where people could use the data to come up with all kind of ideas to disseminate data, to communicate data. And I organized it together with some colleagues from IHE Delft Institute for Water Education. And the winner of that first hackathon was a team that had ideas for developing this WaPLUGIN. And it came reality. The first version was launched in 2022, but the motivation went a bit down. This also has to do with, that big organizations, UN and IHE Delft and other people might not know how software development goes with open source, and that you need to keep people a bit motivated. So you can complain about a lot of features that are not there, and you can send each other emails, but you know what helps us a lot is if you file your bugs in GitHub, and if you try to contribute, and maybe if you use the product and you organize trainings in projects, that you also provide some money so the people stay motivated and improve the product. But fortunately, there was another hackathon in 2023 when the team almost gave up, and some new people joined from Algeria, and they didn't win the hackathon, but they made the original developer so enthusiastic that they didn't quit and continue. And now it's a very alive team. And here I present them. They also put me on the slide, but I'm more like a mentor or facilitator. And the slide needs an update too, because Akshay Donti on the upper left, he just graduated for his PhD at Twente University in the Netherlands on the security of AI for self-driving cars. Super amazing topic. And Fabian is the other developer, works for BMW Group in Munich. And then the Algerian part of the team, Zubida Nemmer, she works at a university in Algeria, in Ouargla, somewhere down in the desert. She's a specialist in geophysics. Then there's Celia Haj Ali working for the largest university in Africa. And Yassine, he works in the same university. So the WAP plugin is capable of downloading WaPOR data from both version 2 and version 3, but I'm going to focus in this presentation on version 3 because that's probably what you are going to use, and version 2 is a bit deprecated. And what it can do, besides just downloading the data, it can also calculate irrigation performance and water productivity indicators for GIS users. And I had to downsample this, but I hope it still is a bit clear. It might improve a bit. So here you see an animation of the plugin after downloading. You can go to the tab WaPOR 3 catalog, and after some initialization, you can choose the WaPOR 3 workspace, which is the one you need to use in the plugin. And there you can see an overview of all the data sets, and they come at different spatial and temporal resolutions. So there's annual data, there's monthly data, and decadal data at each 10 days. And you can clip it to a vector file. I filed an issue to them to not call it shapefile. Hope that will be fixed. And you can modify the default name of the products by adding a suffix so you recognize it for your own project. And it downloads it to a folder, and then it will recognize all the data that you have in that folder. And by clicking load in Canvas, you can then load the clipped data set. So that saves a lot of clicking for going first to the WaPOR portal. And you can include this in your workflows in QGIS. One of the improvements that we will work on is having the tools also available in the processing toolbox, so you can chain it in the graphical modeler or use it in the PyQGIS API. So that's one of the desires if you, as a GIS specialist, want this to chain this to your own models. Oh, yep. So the other thing that it can do, besides downloading the data and clipping it to your study area, is to calculate irrigation performance and water productivity indicators. So really information that can be used to take action in the area. The first indicator is uniformity, which is a measure for how even the water is distributed over the agricultural area, the irrigation scheme. And it's based on the coefficients of variance of evapotranspiration related factors. And it's a non-spatial result that you get out of the plugin. I'll show it in a bit how that works. But there are also spatial results. So there's the beneficial fraction, which is a measure of the efficiency of the water that's applied and the agronomic practices in the use of water for crop growth. And what you see here, that the parcels that are greener are more efficiently using the water, and these are specifically happening in the pivot areas, but you see that others score a bit poor. The legend doesn't show brown, but it should be some color of green, but it's the compression that I had to apply, I guess. Another indicator is relative water deficit, which helps to show which crops or which fields have water stress. So we use parameters to indicate the optimal conditions and how much are the actual conditions. And then we can calculate this relative water deficit. There's also adequacy that is based on the relative evaporation. So we have the actual evaporation based on the actual conditions, but we also know the potential, and then that proportion gives in fact how optimal the crop is using the water based on its demands. And that's also helpful for decision makers there. Then there are some more water productivity related indicators like the biomass water productivity. That is how much of the water ends up in producing the biomass. And also there you see that the irrigated fields and the pivots score higher than, of course, the bare areas that are not irrigated around it. But what we are more interested in is with a growing population and water scarcity is, can we produce more crop per drop? That's the slogan also, more crop per drop. And we can do that by knowing what kind of water is consumed by the plants. So that's the transpiration factor in the hydrology. And we can divide the biomass that accumulates in the plant over the amount of transpiration, so the water consumed by the plant, and that gives us the crop water productivity. And that's a good way to find out which parcels might score bad, and we need to check if that's physical conditions or if it's management, irrigation techniques, because in the end we want to have very efficient water use to produce the same or more amount of crops. So how does this look like in the plugin? So there's another tab, Indicators Calculator. And there you can choose different indicators. And it has an explanation and the equation, and it uses your downloaded folder to already fill in data that it needs. So the AETI is actual evapotranspiration and interception, and the uniformity indicator needs it. It's a non-spatial one, so it just showed the value, but we're going to look now at the spatial one. The adequacy, it also needs the evapotranspiration, so I can change here the output file name, and then I can calculate it. And here's the result, and that can be easily then used for reporting or making a map and take decisions. So what are the other plans? So I already mentioned to decompose the plugin into processing tools, so you can chain it up in your own workflows. Automated seasonal aggregation. Now you can use QGIS tools to aggregate if you have decadal data over a whole growing season, if you know the begin and the end date, but it would be nice to have that in the plugin done for you. To find bright spots and productivity gaps, so more spatial indicator that really shows you where to focus on. Data validation, so you can combine your own data with the results and or with the data set from WaPOR, and it can give you then indicators on how well the WaPOR data matches with your in situ data. And there's some AI developers on board, so we're thinking of automated segmentation for field boundaries. And then, of course, what I promised in the abstract, but what I didn't present about is the downscaling. So that's a bit of a cliffhanger. We will work on that as part of the task in the project. And you will see that in the next FOSS4GE or QGIS conference. If you want to work with the WaPLUGIN yourself, you can find a nice workshop on the GIS Open Courseware platform. There are all kind of free courses there. Also FOSS4GE workshops that I gave in the past. And, so have a look there. You don't need to log in, register, just click on a course and enjoy it. And if you make courses yourself, you can also contact me to have it on the platform. Or if you want to translate existing courses, then I'm always happy. So just contact me. And if you want to know more about the WaPLUGIN or stay in touch with the team, then you can find us on social media. Yeah, I'm happy to answer any questions. Thank you.